Assalamualaikum warahmatullahi wabarakatuh. My name is IZZATI binti ZULKEPLI. I'm from Electronic Image Design. Today I will present body system. Okay, for memory management in body system. In body system, memory allocation and memory management algorithm is actually to manage memory in power of two increments. Initially, memory will be a single contiguous and free block. Here, we assume this memory is 128 megabytes. So, first step, we must assume that a memory size is 2 power of u. We can use anything kind of variable like k, z, or others. So s is a size. In case s is bigger than 2 power u minus 1 and smaller than 2 power of u, it would allocate a whole block and divide the block into it. For example, we have two processes here. So from the 128 megabytes, we must divide by 2. So it will be 64 megabytes. Okay, this block and this block will not add up like this. Okay, for 64 megabytes, we will divide again and we'll get 62 megabytes. So if we divide again, we will not fulfill the process. So we can stop here, then we can allocate the process. First we allocate the process 1, then we allocate the process 2. We must allocate process from lower block to higher block. The difference between fit partitioning and dynamic partitioning. Okay, for fit partitioning is simplest technique. Why? Because the main memory is divided into a fit size in partition, so that there is no limitation on size of process. So the degree of multiprogramming is less. Okay, here we can see that each block is a fixed value. Okay, for dynamic partitioning, it's a complex technique because the main memory is depends the size of process. So does not have limitation on size of process, and the degree of multiprogramming is higher. Okay, we can see there is every process in the different value. Okay, for example, body system. Okay, body system has 4 types, which are binary, Fibonacci, weighted, and ternary. Okay, here I will show the binary body system. Okay, for binary body system, first of all, we will let memory is 1 megabyte. So for the process A, is required 100 kilobytes. Okay, from the 1 megabyte, we will split into 2 parts, 512 megabytes. So now we focus the left side first. Okay, at 512 megabytes, we can split and we get 256. And when we split again, we get 128. And we split again, it will not fulfill the process A. So we just allocate the process A and the balance memory is 28. It's known as a fragmentation, internal fragmentation. Okay, next for process B. Okay, we can allocate 128 kilobyte because it's enough value to support this process. So this is a balanced memory and unused memory. So next for process C. For process C, here this value is not support the process C, so we go to the right side. So we just allocate here because when we divide again, it will not fulfill the process. Okay, next, release B. Release B, that means it will delete the process from the memory. So we just delete and we will total up again and we get 128 megabytes. Okay, release A. So we just delete the process A, we total up again and we get the 512 kilobytes. For Fibonacci body system, it has own number. To determine the number of Fibonacci, is we just add 2 numbers to get the next number. For example, 0 plus 1 will get 1. 1 plus 1 will get 2. 2 plus 1 will get 3. Okay, here it has 377 byte block. So for the process A, request process A is 66. So we must split this block, this memory into 2 parts. Okay, for T77 we can split into 233 and 144. At 144 we can split again into 89 and 55. Okay, so here we can see we can allocate the process A at 89. Okay, for process B is 135. Okay, the right side is not fulfill this process, so we go to the left side. Okay, so for 233 we can split into 144 and 89, so we just allocate here. Okay, next for request C, process C is 70. Okay, 70 is support at left side, so we just allocate here. Next, return A, that means we delete the process A and it will be 144. Okay, next request D, that it means 60. So from 144 we can split into 89 and 55, so we just allocate here. So for weighted body system, it has a use certain formula. first block will use 2 power of k plus 2, where our k is 4. So when we split, it will be 3 times 2 power k and 2 power k. Okay, for 3 times 2 power k, we'll split using this formula, which is 2 power k plus 1 and 2 power k. Okay, for 2 power k plus 1, we must find the new k. So, we must find the new k with using the new formula, which is 2 power k plus 2. We will use the original formula. Okay, so our new k is 3. Okay, so when we split, we will get like this formula. Okay, for 2 power k, we must also find a new k. So, our new k is 2. We are using this new formula, then we will get this like this. Okay, so for this memory also, we must find our new k, and when we split, will be using like this formula. Okay, so for 3 times 2k, when we split, we will use 2k plus 1 and 2 power of k. We use this formula. So for 2k, for this memory, when we split, we must find our new k, which is k is 0, and use this formula, we will still get like this. Okay, so for make it simple, this block, this memory, this system will start the block size 2 power k plus 2, and it will be split on 2 parts using this formula. Okay, for 3 times 2k, when we want to split, we will use 2 power k plus 1 and 2 power k. Okay, the value of k is same like above. Okay, but for 2k, when we want to split again, we must use this formula 2k plus 2 and find the new k. Okay. Okay, next for tertiary body system. Okay, every block size will be split into 3, but only have certain part will be split in 2 parts only. Okay, let me see. Okay, for 2 power of it, it will split into 3 parts using this formula. Okay, so for 2k minus 1, we must find a new k to split again. So we must using this formula 2 power of k, where our k is from 6 is above, and to 5. Okay, so 2 power of 5 we get 32 when we split, and it will be using this formula. Okay, for 16, when we want to split, we must use the new formula. We must use the new find the new value of k using this formula. So when we split, we just repeat the step. Okay, for 3 times 2k minus 3. Okay, it only can split into 2 parts using this formula 2 power of k minus 2 and 2 power of k minus 3. Okay, for 2k minus 3, if we want to split again, we must find the new k, and it can split into 3 parts using the normal formula. Okay, for 3 times 2k minus 3, if we want to split, we just use this formula. Okay, 2k minus 2 and 2k minus 3. Okay, so for 2k minus 3 here, we must find the new k using formula 2 power of k. So we can split into 3 parts using 3 different formulas. So to make it simple, okay, tertiary is a system that must split into 3 parts. Okay, for the first step, the block size is 2 power of k. It can be split using this 3 formula. Okay, for this formula only, we'll split into 2 parts, and no need to find the new k. Okay, next I will show the binary tree. Okay, how to draw that? Okay, it's so simple. If from this is a previous question. Okay, we start at 100 megabytes, so we can divide by 2. So 500 kilobyte here. So first of all, we just focus the left side. Okay, for 512 kilobyte, we can divide by 2 and we'll get 256. And we can divide by 2 and we'll get 128. So it's enough to allocate the process A. So from 128 kilobyte here, we can divide again and get 64 bytes. So it's enough to allocate the process B. Okay, so for process C, it's not divide the memory, it just use here. Okay, so this is how to draw a binary tree. That's all from me. Thank you.